Hi, this is Chapter 2, E-Commerce Infrastructure. In this chapter, we're going to study the origin of and the key technology concept behind the Internet. And also, we're going to study the current structure of the Internet. And also, we're going to study how the web works. And then we're going to study how Internet and web features and service support e-commerce. Also, we're going to study the impact of mobile applications. Tech Titan target a price, bringing internet access to rural India. Class discussion. How can the business opportunity of rural India be assessed? What is rural India's biggest potential? Which of the various methods described for bringing the internet to rural India do you feel might be most successful? We're going to talk about this topic in our classroom. And the internet technology background. Internet. Interconnected network of thousands of networks and millions of computers. Links business, educational institution, government agency, and individual. World Wide Web. One of the Internet most popular services provides access to billions, possibly trillions of web pages. The evolution of the Internet 1961 through present. Innovation phase 1961-1974. Creation of fundamental building block. Institutionalization phase 1975-1995. Large institutions provide funding and legitimization. And also commercialization phase, year 1995 through present. Private corporation take over, expand internet backbone and local service. Although journalists talk about internet time, suggestion of fast phase, nearly instant, worldwide global change mechanism. In fact, today's internet had its start about 57 years ago and evolved slowly in its first few decades before accelerating with the development of the web and mobile platform. The Internet. Internet defined as network that uses IP address, support TCP/IP, provides service to users in manner similar to telephone system. Three important concepts: packet switching, TCP/IP communication protocol, and client-server computing. The client-server computing, Ethernet permitted the development of a local area network and client-server computing in which thousands of fully functional desktop computers could be connected into a short-distance network to share file, learn application, and send message. TCP/IP protocol, the conceptual foundation for a single common communication protocol that could potentially connect any of thousands of disparate local area network and computer, and the common addressing scheme for all computers connected to the network are born. Prior to this, computers could communicate only if they share a common proprietary network architecture. With TCP/IP, computer and network could work together regardless of their local operating system or network protocol. Packet switching, a method of slicing digital message into packet, sending the packet along different communication paths as they become available, and then reassembling the packet once they arrive at their destination. The packet is the discrete unit into which digital messages are sliced for transmission over the internet. So packet switching, a slice digital message into packet. So send packet along different communication paths as they become available. Reassembles packet once they arrive at destination. Uses louder, so less expensive, wasteful than circuit switching. Circuit switching means line switching. And then router is the special purpose computer that interconnect the computer network, then makes up the internet and router packet to their ultimate destination as they travel the internet. The figure 2.3, packet switching. The original text message, I want to communicate with you. Yeah, we can change text message, digitized into bit, and digital bit broken into packet. Also, header information added to each packet indicating destination and other control information such as how many bits are in the total message and how many packets. In packet switching, digital messages are divided into fixed length packet of bit, generally about 1500 bytes. Header information indicates both the origin and the ultimate destination address of the packet, the size of the message, and the number of packets the receiving node should expect, because the receipt of each packet is acknowledged by the receiving computer for a considerable amount of the time. The network is not passing information, only acknowledgement, producing a delay called latency. Full description. A figure illustrates the process involved in packet switching. The process is as follows. Original text message, I want to communicate with you. Text message digitized into bit, which is in the form of a series of zeros and ones. Digital bit broken into packet. Each packet contains 8 bits. Header information added to each packet indicating destination and other control information such as how many bits are in the total message and how many packets. The header information is shown in the form of 3 groups of zeros and ones, 8 bits in each group. TCP/IP. Transmission control protocol establish connection between sending and receiving web computer, handles assembly of packet at point of transmission and reassembly at receiving end. Internet protocol. For TCP/IP layer, network interface layer, internet layer, transport layer, application layer. So TCP establish connection among sending and receiving computer and handle assembly and reassembly of packet. And IP, Internet protocol, provide the internet addressing scheme and is responsible for delivery of packet. So network interface layer responsible for placing packet on and receiving them from the network medium. Internet layer responsible for addressing packet and routing messaging on the internet. Transport layer responsible for providing communication with other protocol within TCP/IP suite. Application layer include protocol used to provide user services or exchange data. So figure 2.4, the transmission control protocol, internet protocol architecture, and protocol suite. So TCP/IP is an industry standard suite of protocol for large internet work. The purpose of TCP/IP is to provide high-speed communication network links. Full description. A flow diagram shows TCP and IP architecture and protocol suite. The diagram has two parts. On the left, the TCP and IP protocol architecture layer are shown, and on the right, the TCP and IP protocol suite lists the protocol within each layer. The layer and the corresponding protocol are as follows. Application layer, which has HTTP, Telnet, FTP, SMTP, and BGP. Host-to-host transport layer, which has TCP. Internet layer, which has IP. And network interface layer, which has Ethernet, token link, frame relay, and TCP. BGP means Border Gateway Protocol. Enable exchange of routing information among systems on the internet. Internet protocol address, IP address. IPv4 Internet protocol address. Internet address expressed as a 32-bit number that appears as a series of 4 separate numbers marked off by period, such as 64.49.254.91. So 32-bit number for a set of number marked off by period, 201.61.186.227. So Class C address, network identified by first three set, computer identified by rest set. Each of the four numbers can range from 0 through 255. This static quad addressing scheme support up to about 4 billion address to the 32nd power. In a typical Class C network, the first three set of number identified network in the preceding example 64.49.254 is the local area network identification, and the last number identify a specific computer. And then, because many large corporations and government domain has been given millions of IP addresses each to accommodate their current and future workforce, and with all the new network and new internet-enabled device requiring unique IP address being attached to the internet, the number of IPv4 address available to be assigned has shrunken significantly. Registry for North America, Europe, Asia, and Latin America have all essentially run out. So IPv6 was created to address this problem. An IPv6 internet address is 128-bit, so it can support up to the 128th power. So 128-bit address able to handle up to 1 quadrillion address. IPv4 can handle only 4 billion. According to Akamai, in the United States, about 40% of internet traffic now occur over IPv6. Belgium leads the way globally, with over 46% of internet traffic converted to IPv6. Figure 2.5, routing internet message, TCP/IP, and packet switching. The internet uses packet switched network and the TCP/IP communication protocol to send, route, and assemble message. Messages are broken into packet, and packet from the same message can travel along different routes. Full description of flow diagram shows how internet messages are routed using TCP and IP and packet switching. The diagram shows a sender and the recipient connected by many routers. The three stages in the process of sending and receiving messages are as follows. First, TCP and IP break data into packets when they leave the sender machine. Second, the packet travel from router to router over the internet. And third, TCP and IP reassemble the packet into the original whole when it reaches the recipient machine. From sender, TCP/IP break data into packet. The packet travel from router to router over the internet. And TCP/IP reassemble the packet into the original whole and then arrives recipient. Domain name, DNS and URL. Domain name, IP address expressed in natural language. Domain name system, DNS, system for expressing numeric IP address in natural language. So allows numeric IP address to be expressed in natural language. And uniform resource locator, URL, the address used by a web browser to identify the location of content on the web. So the example you can access. And client and server computing. While packet switching exploited the available communication capacity and TCP/IP provide the communication rule and regulation, it took a revolution in computing to bring about today's internet and the web. The powerful personal computer client connected in network with one or more server perform command function for the client. Storing file, software application, and access to printer and so on. The mobile platform. Primary internet access is now through tablet and smartphone. So tablets supplement PCs for mobile situation. Over 160 million people in United States use internet with tablet. Smartphones are a disruptive technology, new processors and operating system. Over 230 million in United States access internet with smartphone. Today, the primary means of accessing the internet worldwide is through highly portable smartphone and tablet computer and not traditional desktop or laptop personal computer. This means that the primary platform for e-commerce product and service is also changing to a mobile platform. The Internet Cloud Computing Model. Firms and individuals obtain computing power and software over Internet. Three types of service: infrastructure as a service, software as a service, platform as a service. There are public, private, and hybrid cloud service. So, cloud computing, model of computing in which computer processing, storage, software, and other services are provided as a shared pool or virtualized resource over the internet. Infrastructure as a service. Customer use processing, storage, network, and other computing resources from third-party provider called cloud service provider to run their information system. For example, Amazon used the spare capacity of its information technology infrastructure to develop Amazon Web Service, AWS, which offer a cloud environment for a myriad of different IT infrastructure services. Software as a service, SaaS. Customer use software hosted by the vendor on the vendor's cloud infrastructure and delivered as a service over a network. Leading software as a service example include G Suite, which provide common business application online, and Salesforce.com, which provide customer relationship management and related software service over the internet. Platform as a service, PaaS. Customer use infrastructure and programming tools supported by the CSP to develop their own application. For example, IBM offer IBM Cloud for software development and testing on its cloud infrastructure. The Internet Cloud Computing Model drawback. First one is security risk. And then second one is shift responsibility for storage and control to provider. As you know, the public cloud, the third-party service provider that own and manage large scalable data center that offer computing, data storage, and high-speed internet to multiple customers who pay for only the resource they use. Private cloud provides similar option as a public cloud, but only to a single tenant. So they have advantage of security. And hybrid cloud offer customer both the public cloud and private cloud. So radically reduced cost of building and operating website, infrastructure, information technology support, hardware, and software. Other Internet Protocol and Utility Program. Internet Protocol, HTTP, Hypertext Transfer Protocol, the Internet Protocol used for transferring web page. Email, and SMTP, POP3, IMAP. SMTP, Simple Mail Transfer Protocol, the Internet Protocol used to send mail to a server. POP3, Post Office Protocol 3, a protocol used by the client to retrieve mail from an internet server. IMAP, Internet Message Access Protocol, a more current email protocol that allows users to search organize, and filter their mail prior to downloading it from the server. Utility program. Ping Tracert. Ping is a program that allows you to check the connection between your client and the server. Tracert, one of several root tracing utility that allow you to follow the path of a message you send from your client to a remote computer on the internet. Packet Internet Grouper, we call this ping. And then there are another terminology, FTP, and then Telnet, and then SSL. FTP, File Transfer Protocol, one of the original internet service, part of the TCP IP protocol that permit users to transfer file from the server to their client computer and vice versa. Telnet, a terminal emulation program that runs in TCP IP. And Secure Socket Layer, SSL, Transport Layer Service, TLS, are protocols that operate between the transport and application layer of TCP IP and secure communication between the client and the server. Internet infrastructure, internet growth has boomed without disruption because of client-server computing model, hourglass layered architecture, network technology, substrate, transport service, and representation standard, middleware service, application. In 2018, there are an estimated 3.6 billion internet users worldwide, up from 100 million users at year-end 1997. While this is a huge number, it still represents less than half, about 49% of the world population. eMarketer Incorporation 2008. Although internet user growth slowed in the United States and Western Europe in 2018 to about 1% through 2% worldwide, the growth rate was about 5%, with the highest growth area being the Middle East, Africa, growing at over 5%, and Asia Pacific. By 2022, it is expected that there will be over 4.2 billion internet users worldwide. Figure 2.10, the hourglass model of the internet. The internet can be characterized as an hourglass modular structure with a lower layer containing the bit carrying infrastructure, include cable and switches, and an upper layer containing user applications such as email and the web. In the narrow waist are transportation protocol according such as TCP/IP. Full description: the hourglass model shows 4 layers. 2 layers are above the narrow neck of the hourglass, and 1 layer is below it. The layer from the bottom to top are as follows. Layer first, network technology substrate. It includes the following options: coaxial cable, fiber optic, wireless, satellite, LAN, and DSL layer. Second, transport service and representation standard, which include the IPv6 and IPv4 and TCP protocol. Layer 3 middleware service includes storage repositories, security authentication / identity manager, and file system. Layer 4 application include web browser, email client, media player, image server, and remote login. The application layer contains client and applications such as the web, email, and audio and video player. The middleware service layer is the glue that ties the application to the communication network and includes such service as security, authentication, address, and storage repository. Figure 2.11 Internet Network Architecture. Today's Internet has a multi-tier open network architecture featuring multiple backbone, regional hub, campus, corporate area network, and local client computer. Full description: schematic diagram shows Internet network architecture with the backbone, regional hub, domain, and various clients. The network diagram shows a backbone network connected to regional hub, comprised of 2 regional hosts and connected to each other. One regional host is connected to a domain by a T1 line. The domain is connected to a campus network and office through a T1 line, each of which have a client IP address. It is also connected to POP3 mail and SMTP mail. Another regional host is connected to a domain local internet service provider. This domain is connected to a home system through DSL or cable line. The home system has a client IP address. The internet backbone comprised of fiber optic cable, hundreds of glass strands that use right to transmit data, faster speed and greater bandwidth, thinner, wider cable, less interference, better data security. Tier 1 internet service provider, Tier 1 internet service provider or transit internet service provider. Numerous private networks physically connected to each other. Undersea fiber optic satellite link. Fiber optic cable consists of up to 100 of strands of glass or plastic that use right to transmit data. Tier 1 internet service provider own and control the major long-hour fiber optic cable network comprising the internet backbone. Bandwidth measures how much data can be transferred over a communication medium within a fixed period of time. It is usually expressed in bit per second, kilobit per second, megabit per second, or gigabit per second. Bandwidth measures how much data can be transferred over a communication medium within a fixed period of time and is usually expressed in bit per second, kilobit per second, megabit per second, or gigabit per second. In the United States, the backbone can carry data at a rate of up to 100 gigabit per second. Internet Exchange Point, IXPs. Regional hub where Tier 1 internet service providers physically connect with one another and with regional Tier 2 ISP. Tier 2 ISP provide Tier 3 ISP with internal internet access, originally called network access point, NAPS, or metropolitan area exchange, MAE. But now are more commonly referred to as Internet Exchange Point. And then Tier 3 Internet Service Provider, firm that provide the lowest level of service in the multi-tier Internet architecture by leasing Internet access to homeowner, small business, and some large institution. Narrowband, the traditional telephone modem connection, now operating at 56.6 kilobit per second. Broadband refers to any communication technology that permits client to play streaming audio and video file to acceptable speed. Tier 3 Internet Service Provider, retail provider, risks Internet access to homeowner, small business, large provider, Comcast, Charters, Spectrum, AT&T, Verizon, Altice, smaller local provider, services, narrowband, broadband, digital subscriber line, cable internet, satellite internet. Digital subscriber line deliver high-speed access through ordinary telephone line found in home or business. FiOS, fiber optic service, a form of digital subscriber line that provides speed of up to 500 Mbps. Cable internet, piggyback digital access to the internet on top of the analog video cable, providing television signal to a home. Tier 1, T1, an international telephone standard for digital communication that offer guaranteed delivery at 1.54 Mbps. T3, an international telephone standard for digital communication that offer guaranteed delivery at 45 Mbps. Campus Corporate Area Network, local area network operating within single organization such as New York University or Microsoft Corporation, with internet access directly from regional and national carrier. Mobile internet access, two basic type of wireless internet access: telephone-based, mobile phone, smartphone, computer network-based, wireless, local area network-based. Telephone-based wireless internet access, currently based on third generation and fourth generation technology. Fifth generation will provide higher bandwidth with speed reaching 10 gigabit per second or more. Wireless local area network based internet access, Wi-Fi, various 802.11 standard, high-speed fixed bandwidth, wireless LAN, wireless access point, hotspot, limited range but inexpensive. WiMAX and Bluetooth. Wi-Fi wireless standard for Ethernet network with greater speed and range than Bluetooth. And as you know, WiMAX is high speed, range and speed 30 mile and 50 through 70 megabit per second. So high speed, medium range, broadband wireless metropolitan area network. Bluetooth wireless personal area network. 1 through 30 meters and 1 through 30 megabps speed. So modest speed, low power, short range connection of digital devices. Figure 2.13 shows the Wi-Fi network. In a Wi-Fi network, wireless access point connect to the internet using a land-based broadband connection. client, which could be desktop, laptop, tablet computer, or smartphone, connect to the access point using radio signal. Full description on image shows various connection to Wi-Fi network. The image shows a wireless access point in the center connected to the internet, laptop computer, smartphone, tablet computer, and desktop computer. The connection between the internet and wireless access point is Rebel broadband connection to internet. Other innovative internet access technology, drone, volume, and white space. Google Project Loon, Facebook Connectivity Wrap, a killer drone, Microsoft Airband Initiative, white spaces. The Internet of Things, IoT, object connected via sensor RFID to the Internet, smart thing, interoperability issue and standard, the security and privacy concern. So Internet of Things, use of the Internet to connect a wide variety of device, machine, and sensor. No discussion of the Internet would be complete without mentioning the Internet of Things, also sometimes referred to as the industrial Internet. Internet technology is spreading beyond the desktop, laptop, and tablet computer and beyond the smartphone to consumer electronical appliance, cars, medical devices, utility system, machine of all types, even clothing, just about anything that can be equipped with a sensor that can collect data and connect to the internet, enabling the data to be analyzed with data analytic software. Internet of Things built on a foundation of existing technologies such as radio frequency identification tag, and is being enabled by the availability of low-cost sensor, the drop in price of data storage, the development of big data analytics software that can work with trillions of pieces of data, as well as implementation of IPv6, which will allow internet address to be assigned to all of these new devices.